Hey guys, welcome back to the series for how to build your own hydrofoil. In this video, we're going to cover how you can build the aluminium fuselage. So let's get into it. Okay, so for the design of this hydrofoil, using the aluminium fuselage has a couple of benefits. The reason that we've put it into the design is that you can actually build this using the same woodworking tools, so carbon tipped tools that you might be using to do woodwork anyway. And by building this solid aluminium fuselage, it's very durable, it's very strong, and by organizing our set out so that a uniform screw set out, you can use this same fuselage for multiple wings. So if you want to make an experiment, different wing sizes, different shapes, then you can actually just build the fuselage once and then you've got it, and you can play around with those different wing designs. So for this actual design, as you can see, I've got two pieces of aluminium here. This is extruded aluminium 6061 grade. This piece is the same size or same dimensions as the previous fuselage. So if you're looking at the end section, we have 3/4 of an inch by 1 inch, or 19 mils by 25 millimeters. This piece is square, so it's 25 millimeters by 25 millimeters, or 1 inch by 1 inch. And it adds a little bit of weight, but I'm going to be using this one for this design right now. As I did touch on in earlier videos, you really could use either. So you could use either of these pieces of aluminium, whatever you can source, you could use. In my opinion, I think it's worth using this lighter size for any wing size that is approximately this 866 size and under, and then using the 1 inch by 1 inch for the 866 size and above. So if you're going to build a 1200 square centimeter wing, you're better off using the 1 inch by 1 inch aluminium for that. The difference in weight, I'll show you. It's about 300 grams different. So the weight of the 3/4 inch by 1 inch is about 880 grams. And then the weight of the 1 inch by 1 inch is about 1170. So there's about 300 grams different there. The whole assembled unit, these wings weigh they're super light. So if I put the wing on there, it's about 400 grams or so. I mean, that is like really light. So most of the weight in this assembly is definitely in the fuselage. The reason that we're going with the heavier duty fuselage is just to increase the strength of that front connection point. There's a couple of different ways of looking at it. So let me just talk about why we're doing aluminium at all. If we circle all the way back to the very first video about the design principles and why we've designed it the way that it has been designed, one of the considerations was that for a lot of people when they're building their own hydrofoils, the weak point, or the failure point, in my opinion, can come from with the mast, and actually the connection points from the fuselage to the mast and from the mast to the base plate that joins onto the board. I think that can be one of the sort of downfalls of people that are trying to build their own system. And so that was a lot of the big reason why we're using a production mast to connect to the fuselage. The reason is, when you look at this profile, how slim this is and how strong that is, if you look at the bottom as well, it's very hard to build something like this at home that's strong enough. And so what happens is everyone has to build an oversized mast, which creates a lot of drag running through the water. Also, in order to make a strong connection point, so if we look at where the fuselage here actually connects, the way we connect it to the mast is with these 3 screws, and they literally just screw in to the mast. And you can see that creates a really nice, strong connection point in between the fuselage and the mast, and very hydrodynamic still. Now, of course, you could build your whole mast. You know, people try and build carbon masts. So they wrap plywood with carbon, and they try and do the same thing for the mast and the fuselage. But in my opinion, you're better off just going with the aluminium. You know, the thought is that you can make it lighter using carbon. But by the time you add a wood core and then have enough carbon to make it strong enough that it doesn't fail over time, I think for a DIY project, definitely worth going with the aluminium. Also, it depends how you like to foil, but this acts slightly as an anchor. The aluminium fuselages allow the foil or the board to sit flat on the water and the foil to go down, the mast to go directly down. Some of the lighter foils, they actually sort of float up, and so the foil will sit on the water sort of sideways. It depends, it's a preference, but I actually prefer it when it sits flat. I find it's more similar to when I'm riding my strapless surfboard. The board sits flat on the water, and then I pull myself up onto it. And also, if you're winging, it can be helpful as it actually anchors the board down. So on a sup or something, it actually holds it down flat. It's, you know, it is a preference thing. Some people prefer it when it floats, but it's not the end of the world, is what I'm trying to say. It's not terrible to actually have it anchor down like that. So you can, the design, this screw set out is designed for this Flukes production mast. Now, this, as I touched on at the start, you can just change this set out. I'm obviously going to be drilling these holes at this spacing so they'll connect to these masts. You can buy these masts on our website, or you can connect it to any mast that you have that already has screws. So it's completely up to you, but you'll just need to measure your own and then set those screw holes out. Of course, in the fuselage, what the second step here is that we have these holes to connect our wings to. Now these holes are actually threaded, so we tap them with a thread, and then the wing will actually sit on top of that like that. You can see we line up the screw holes, and then using the screws, we actually screw it straight down onto the fuselage. Now, one thing that I'm trying to improve in this design is the strength of this connection, as I've mentioned. So that's why we're going to the 1 inch by 1 inch. The reason that this connection needs to be really strong is the leverage from side to side. Once those screws are done up, the leverage from the width of the wing. So the wider the wing, the more leverage there is. When you change your weight up on the board, as that sort of pushes on those wingtips, then this connection point needs to be nice and strong. So that's why we're going to 5 screws in this new design, and the wider fuselage. But the main thing to keep these connection points strong, because they're not a socket connection, and that's same with where the mast connects to the fuselage. This is, if you look at this is a socket connection, where this actually, the other way around, slides over at first, and then you screw down. And so that the screws hold it, but then that socket stops any big movement happening. Because we're just doing a direct screw connection, which I've found to be fine, but one of the things you have to do is make sure your screws are nice and tight. If the screws get loose, then that creates a lot more play in these connection points. So even, you know, mid-session, particularly for your first few sessions, just crank those screws up nice and tight and make sure that all those connection points are really strong, and then it will stay very strong. If you let that get loose, then that's where you can run into trouble with things starting to wiggle around. So now let's have a look at the actual dimensions of the plan, and then we'll start setting out the aluminium. Let me just put this down. Okay, so if we take a look at the actual plan, it's quite a simple design, where we're going to start by, you can see on the center, we do all of our holes are on center. So we set up our drill press so that we can drill on the center of the fuselage, so it'll be literally just right down the middle. And the reason I'm pointing that out is that it doesn't matter if you're using this thickness or this thickness or any thickness, it's always just straight down the center of the fuselage. So what we'll be doing is, you can see we have some holes that they're all through holes. We drill them all the way through. These are actually a 6.5 or a 1/4 inch hole. And then these are all done with a 5mm drill bit that we then tap with an M6 size tap. So if I open this up. So this is a tap and die set. The only one that you need for this whole project is this one, which is an M6 tap that we'll be using to actually to thread those screws so we can screw the wings on, but the mast connections are just a complete hole all the way through. Once we've drilled our holes, then we're going to be shaping the fuselage. So as you can obviously see here, we take some of the bulk out of the fuselage. This will help with the hydrodynamics at the front and also reducing the weight by slimming these down, and then we'll shape it up with a router. Like I said at the start of this video, you can use all woodworking tools in order to do this. If you haven't worked with metal before, then you can use all the same tools to actually shape up the fuselage that you would to shape up a piece of wood. So look, I think that's it for the design, and the next step really will be to start machining it. So I'll pack this up, we'll get the tools ready, and we'll start machining the aluminium. Okay, so the first step is to cut the fuselage to length. So specified on the plans, we have 670mm. I think that's a good length. You can change the length if you want to, but I think that's a good all-round length. So I'll be marking it to 670, and then actually cutting it on a drop saw. The drop saw with the tungsten carbide tips will cut all the way through the aluminium, like I mentioned. Whenever I'm cutting aluminium on these tools, I always clamp the piece though. I really don't like to just hold it. There's definitely a little more force that goes into it. So I line it up, 670. I like to have a backing piece there as well, just because of the way that the fence actually finishes sort of a bit far back for my liking. Hold it down and give it a clamp. So it's going to make it a lot easier. You don't need to use any lubricant necessarily in order to cut through. So safety goggles, of course, and let's cut it. So the second step, we're going to drill the 5mm holes to connect the wings. So we'll be drilling these 1, 2, 3, 4, 5 at the front and the 2 at the back with a 5mm drill piece. I've got the 5mm drill piece already in, and if you have a drill press, I'd highly recommend that you use one. It's going to keep it square and true as you're drilling through the aluminium. But regardless of how you do it, the number one thing is that we want to mark the holes where they connect to the other items. So what I'm saying is, on the top, if you mark your fuselage now with a T, so that's the top, or up, you could write up. What we want to do is, wherever we have the front, we want to mark the holes on the top side where it will connect to the wing, and then on the back, we want to mark the holes on the bottom side where they're going to connect to the wing, and we want to drill from those sides to make sure that we don't have the drill wander at all, which it will. Even on the drill press, it won't be 100%, especially with sort of a cheaper drill press like this. And so as long as you mark from where it's going to connect, then where the screw enters on the other side, it might not be, it will still work because it will be in the right spot on where it connects. So now the first thing I like to do is just set up the machine into the center. So what we want to do is, you can see I've got a base and also a fence, and I'm going to clamp this in position so that it's marked exactly in the center of this, so that if I turn it around, flip it upside down, it's always going to be in exactly the right spot. So the first step is to, of course, just mark the center. So if we come, I'm actually just going to come to here where there's not going to be any actual holes. So it's exactly 25mm, so we're going to go 12.5 right into the center there. like that. Like that. That looks pretty good. And then the way I like to do it is actually start by put it close. Start by clamping one side. And then you can sort of move this until it's perfect. Bring the drill down. So setting this up correctly now is going to make everything else a lot easier. Looks pretty good there. And just make sure that you have the drill plumb or square from either side, double checking either side, also front to back. I've already set the machine up to make sure it is square all that way, but you'll definitely want to check that that's all in, if that's all correct as well. And then we can mark out our holes. So I've marked the top, so I might mark the top, and also I might just mark the front so I know where that is. And because we know that we have this set exactly in the center, the holes will be in the center of the fuselage, all we have to do is measure out our distances that are specified here. So starting at the front, I'll turn it around so it's in the same relationship to the plan, and we just start at the front. I prefer, they're actually, you can see the measurements go all the way from the front, so you don't have to move your ruler. That makes sure everything will be perfect. So we're starting with 15, 40, 65, 90, 115, and I'm actually going to mark, I will come back. For the sake of this video, we'll come back and we'll mark these ones afterwards. And then remember, we want to mark from the bottom for the back wing, so we flip it over. Coming in from the back, we're going to go 35 and 65. And there are our markings. So just like we did with the saw, I like to clamp this in position. So now that we know we're in the center, turn this around, get this in exactly the right spot. In the past, I have actually used a center punch. I've marked it out perfectly and used a center punch so that the drill doesn't wander. As you start to bring it down, it doesn't wander. If you're hand drilling this, you'll definitely want to punch this. So you'll need to mark a line all the way down the center of the fuselage, mark all of those lines, get a sharp center punch, hit it with a hammer so that the front or the tip of the drill will seat in there and it won't wander while you're initiating that drill. I found with the drill press, I actually prefer not to center punch it, just in case my center punch is just slightly off, and I actually just bring it down and let it just rub on the top, on the surface very gently, and it'll create its own little center, and then I can pull it through. So depending on how you're drilling it, if you're drilling it by hand, you'll definitely want to punch these. So once you're happy that it's in position, I clamp it in position there, and now we know, if we look nice and close, we're at the first mark, no problem, and we're in the center of the fuselage from side to side, and they're all going to be uniform. So we can start by drilling our very first hole, I should say. I actually use a bit of lubricant. You could use different types of lubricant to drill through. This is my only 5mm drill bit, because here in Canada, particularly where I am, they're all imperial. So I've got just a million imperial drill bits, which are just slightly different to the 5mm. So I have to be careful with this one. So I'm going to drill it through very slowly to make sure that I don't break it. So I like to use a bit of lubricant and just bring it down nice and slow. So let's drill our first hole. First, just bring it down very slowly. See, it starts to build its own center punch right there. See, it will mark it. So that's how I prefer to do it, just nice and soft to the start, and then we can, once it starts to create its own spot, when you're drilling, you don't want to just drive it all the way through. Bring it down, clear out the hole, let it come back up, bring it down again. So I just like to put a little drop of oil in there. And I find that's just a bit easier on the tool. Aluminium has a tendency to get trapped around the actual tip of the drill, so that's what the oil also helps with as well. Stops that happening. As it starts to come close to the other side, I like to slow down a little bit just so it doesn't break through the bottom. So when you know you're nearing the bottom, you can just slow down with the pressure. Okay, and then we have it. The first hole is drilled. So instead of taking everything out, I just like to release the clamp and just slide this along to the next location. Bring the drill down, make sure you're in the center again. Right there. Tighten it up. And we'll repeat the process for the rest of these holes. So now we've drilled through for the connection points for the front wing and the rear wing. We'll mark out for the mast connection. So working from the front again and from the top, so the same side that we drilled the front wing. Come back 177 plus 40 plus 80. So the first one is at 177. And then I like to move to the 100 and then go 40, 80. And then that way we know that each of those holes is 40 millimeters apart, and the first hole is 177 from the front, and so that's perfect position for the mast. So this is, of course, is to connect the Flukes production mast to the fuselage. And we're going to be drilling this as specified with a 6.5 millimeter drill or a 1/4 inch drill. So I'm going to undo the drill and swap the drill piece out, but of course not move the fence, because the fence is already set. We're using an M6 screw, so really an M6, really well drilled out would actually work, but I find just that bit of tolerance as it's going through the fuselage with that extra 1/2 millimeter actually helps just when you're assembling it to the mast. And when you nip it up, it doesn't move around, so it's not a problem. And what I like to do is actually also go to the same side. So of course we drilled off this side of the fence. The mast was sticking out this way, so I like to do the same for these as well. It just means that these will definitely be all in exactly the same position, even if you're very slightly out. So we move it, it's exactly the same process. Clamp it in position, looks good, and we drill. Same deal, just very gently, just let it create a seat for it, and then so now we've finished drilling the holes. So you can see we've got the holes ready to tap for the front wing, from the bottom side ready to tap for the rear wing, and the 3 holes for the mast connection. So that's great. The next step, I actually like now to shape the fuselage. So we'll be doing the tapers. We'll pull up the existing one, off the front, off the rear, and off the sides of the rear. So I like to do the tapers first, and then actually come back and tap the holes. So we'll put the threads through the holes after the tapers are done, mainly because we'll be taking sort of a big section off this, so it just makes the tapping a bit easier. You don't have to go through the full thickness for every single tap. So in order to do that, we're going to get set up. Let's mark the fuselage out, and I'll show you how I use a couple of jigs to actually run this through the table saw.